Hello juniors, today we're going to continue analyzing triangles and today we're going to see the cosine rule, right? We have already seen the sine rule and now we're going to see the cosine rule. So the objectives for today's class are two. Number one, find the length of sides of oblique triangles, and number two, find measures of angles in oblique triangles. So we're going to start this by doing a demonstration of where this famous cosine rule comes from, just for you to understand that it's not a formula that you need to memorize, but rather you can analyze it by looking at any type of triangle. So as always, I'm going to draw, or we have here, an scalene triangle, right? This is not a right angle triangle. This is not an isosceles triangle. This is not an equilateral triangle. It's a random triangle from which we can make this demonstration, okay? So you see that it's triangle ABC. I'm going to erase this for a second. Triangle ABC, where we have side C, side A, and side B, right? You already know the rule to name each side. So we're going to do as the same thing we did for sine rule. We're going to trace the height of this triangle, considering that this is the base, side C is the base. So we would have the height right here, height, and I'm going to call this remaining side, I'm going to call this, now I'm going to call it D here, and I'm going to call this part over here, I'm going to call this X, the remaining side here. So if this is X, then and all of this is C, then the remaining side here would be C minus X, okay? I'm going to need those two sides to do this demonstration. So first of all, we're going to work with triangle ACD, okay? ACD, which is this small triangle over here, which is a right angle triangle, right? Because this is also a right angle right here. Okay, so if we work with triangle ACD, I'm going to use the Pythagorean theorem to find our first relationship. We're going to say that the hypotenuse, which in this case is b squared, is equal to h squared plus x squared, right? Then if I solve for height, I'm going to get that height squared is equal to b squared minus x squared, okay? And I'm going to call this equation number 1, okay? We're going to be using this later on. Then I'm going to look at triangle BCD, the other right angle triangle that is formed here, right? So I'm going to call this triangle BCD. And we're going to say that for this triangle, A is our hypotenuse, right? So I'm going to apply again Pythagorean theorem, and I'm going to say that A squared is equal to h squared plus c minus x squared, okay? Once again, I'm going to solve for h. I'm going to leave the h alone. So this is h squared equals a squared minus c minus x squared. I'm going to call this equation number 2. I don't need the points. Equation number 2, okay? So you see that in equation number 1, we have h squared alone, and here we have h squared alone as well. So I can equate both equations, or both expressions. So we're going to say that we're going to equate equation number 1 with the second expression. So we're going to get that. Instead of writing h squared, I'm going to write b squared minus x squared should be equal to this expression over here, right? A squared minus c minus x squared. Okay, and then I'm going to try to solve this, or to expand this in organized terms. So if I expand this, I'm going to get b squared minus x squared, and on this side it will be a squared minus. And you should already know how to expand this, right? We need to square c squared, minus 2 times c times x, plus x squared. That's how you expand this expression over here. Okay, then we keep on organizing terms. B squared minus x squared is equal to a squared. We distribute the negative sign, so it's minus c squared plus 2cx minus x squared, okay? And then if I, for example, take this x squared to the other side, we're going to get that this is b squared minus x no, sorry, I'm going to take it to the other side. So b squared is equal to a squared minus c squared plus 2cx plus 2cx minus x squared plus x squared if we take it to the other side. So we see that this term simplifies right here, okay? So then what else can I do here? I'm going to write this as, I'm going to take this a right here, and I mean, I'm going to take all of these terms, right, to this side just to have all of the terms positive, okay? So I'm going to have it this way. A squared, if I leave the a alone here, we're going to have b squared plus c squared minus 2cx, okay? And if you remember from the cosine rule, you see that this is very similar already to the cosine rule, but we still need to work with this x over here. So I'm going to leave it right there, and then we're going to go back to this triangle again, triangle ACD. So if we look again at triangle ACD, we're going to, we see that, for example, if we find the cosine of angle A, cosine of angle A is adjacent over hypotenuse, right? So there I'm going to find a relationship here. So cosine of angle A is equal to adjacent, which is x, divided by the hypotenuse, which is b. So if I leave the x alone, if I solve for x, we're going to get that x is equal to b times cosine of angle A. So if I go back to this expression over here, the one we had here, and I replace this, this equivalent value for x right here, then I'm going to get the cosine rule, right? So I'm going to do this with a different color to avoid confusion, maybe blue. We're going to say that a squared, if I plug in this right here, we're going to have that a squared would be equal to b squared plus c squared minus, let me see if I can make this fit here. If I take all of this a little bit more to the left, there. So a squared plus b squared plus c squared minus 2c, and instead of x, we're going to write b cosine of a, right? So then I can, so actually there you see that this is the cosine rule, right? If I reorganize terms, instead of writing cb, I'm going to write bc. So we're going to have that a squared is equal to b squared plus c squared minus 2bc cosine times cosine of angle A. And this is exactly the cosine rule, if you remember. So this is where it comes from. You see that we're always going back to right angle triangles in order to make our demonstration, okay? So you see how right angle triangles are very useful when solving different types of triangles. Okay, so that's the cosine rule, and that's where it comes from. It says, the cosine rule. For triangle ABC, where A is the length of the side opposite to angle A, B is the length of the side opposite to angle B, and C is the length of the side opposite to angle C, we have these three different forms of presenting the cosine rule. This is the one we demonstrated in this problem. A squared equals b squared plus c squared minus 2bc cosine of A. Or we could also express it this way, right? B squared equals a squared plus c squared minus 2ac cosine of B. Or c squared equals a squared plus b squared minus 2ab cosine of C. All of these formulas are in the formula booklet. Let me show you this quickly. If we go to the formula booklet, this one. Here you see the three rules we have studied up to now for any type of triangle: the sine rule, the cosine rule, which is presented in this way in the third format, and the area of the triangle, which we have already seen during the last classes, okay? And now we're going to see what this is about, but it's basically the cosine rule where we solve for the angle instead of for a side. Okay, if we go back, it says, you can usually use the cosine rule when you are given two sides and the included angle, side, angle, side, or when you are given three sides and want to work out an angle, side, side, side. Basically, what I told you from last class, if you're given 3 pieces of information of 3 different letters, then you're gonna apply a cosine rule, okay? Let's see an example to see how this applies. It says, find A and the missing angles in this triangle. So we want to find side A and the missing angles. So I see that, for example, I have one side, which is side C, we have side B, and we have angle A. So we have 3 different letters as our data, right? Side B, side C, angle A. And if you want to look at it this way, it's 2 sides and the included angle, right? So we can apply, in this case, cosine rule, right? So if we apply cosine rule, we're going to say that if we want to find A, maybe it's more convenient to use this format, right? So we're going to say that A squared, let me copy a formula first, A squared equals B squared plus C squared minus 2BC times cosine of angle A. So if we fill in the information, we're going to have that A squared is equal to B squared, that's 8.9 squared. Then we have plus C squared, 13.2 squared, minus 2 times B, which is 8.9, times C, which is 13.2, times cosine of angle A, which is 80 degrees. Remember that if you're given the angle in degrees, your calculator must be set up in degrees. Okay, so if we solve this, you're going to get that A squared is equal to 212.65. So if we take a square root from both sides, we're going to get that the square root of A squared is the square root of 212.65. That means that the value of A is equal to 14.6 centimeters if we round it to 3 significant figures. Okay, so this is side A. But now we're missing, we already have this value. This would be, let me write it here, 14.6 centimeters. We're still missing this angle and this angle. How can we find those angles? Well, I could, if I want, apply cosine rule, or the easiest way is to apply sine rule, which is what we have seen during the last classes. So I'm going to apply sine rule, right? Sine rule. Just for the record, if you take a look at this exercise as it was originally without this side, you would see that sine rule is not applicable, right? Because for sine rule we need 2 data of the same letter, and we do not have that in this situation. So if you try to apply sine rule, you would see that you won't be able to solve the equation. You would have 2 variables. Okay, so if we apply sine rule, now I can use, for example, this pair of values, angle A and side A, and I can relate it with this pair of values to find angle B, for example, right? So I'm going to say that side A, which is 14.6, is to sine of angle A, which is 80 degrees, as side B, 8.9, is to sine of angle B. So if I solve this, you already know how to solve it. I'm going to put the answer directly. Angle B would be equal to 36.9 degrees. 36.9 degrees. So that's angle angle B, sorry. So once we have angle B, which is this one over here, 36.9, how can we find angle C? Well, again, we could, if we want, apply sine rule and do exactly the same process we did for angle B, but there's an easier way. If we already have these 2 angles, then finding angle C would just be finding the angle required to get to 180 degrees, right? So it's much easier to just work it that way. So we can say that angle C, is equal to 180 degrees minus the addition of both angles, 80 plus 36.9. So if we work this, we're going to get the answer, which would be 180 minus that, it's 63.1 degrees. So this is the missing angle we had left here. So this angle is equal to 67.1 degrees. And there we have solved the whole triangle. So I think this is easy, right? let's see this. It says, when you use a cosine rule to find angles, it is sometimes helpful to rearrange the formula like this. You see that this is exactly the same formula we were looking at before. It's exactly this formula right here, but now we just solved for cosine of A, for example. We left this term alone, and by doing that, we took all of this to the other side, and then this goes dividing to the other side, and we get this new format of the formula, which is this, right? But the formula is exactly the same one. There's nothing new here. Okay, so this might be useful in case you want to find angles more quickly, right? But you can always use the original formula and you would get the same result. So let's see an example of how this applies. It says, find angles A, B, and C. So in this case, we have the three sides already. And if you try, you would see that it's impossible to apply sine rule because we have three different information from three different letters, right? So we will not be able to apply sine rule. So I will need to apply cosine rule. And for example, we can start by looking for angle A. So we're going to apply this formula over here. So let me write that down. We're going to say that cosine of angle A is equal to, and I'm going to write the information already. It's B squared plus C squared minus A squared. So B squared is 6.56 squared plus C squared, that's 3.63 squared, minus A squared, which is 8.28 squared. This is being divided by 2BC, right? So 2 times B, which is 6.56, times C, which is 3.63 millimeters, right? So if you solve this using calculator, you would have to do all of this and then apply shift cosine of that in order to solve for the angle, and you should get as an answer 105 degrees. So this is angle A, which is 105. Once you have found angle A, you could, if you want to simplify this, now you can apply sine rule. For example, we already have this pair of values, so we can find this angle or this angle. So we could apply sine rule, or if you prefer, you could again apply, for example, this formula and you would find angle B, and this formula and you would find angle C. I think that's a little bit longer than just applying sine rule, so I'm gonna stick with sine rule to find angle B, for example. Let's work with angle B. If I apply sine rule for angle B, we're gonna say that for example, 8.28, which is side A, is to sine of angle A, 105 degrees, as side B, which is 6.56, is to sine of angle B, which is what I'm looking for, right? So if you solve this using your calculator, you would get an angle B, which is equal to 49.9 degrees. I'm not showing this whole process of finding the angle because I think you should already know this by now, and it's just plugging in the information in the calculator. So I don't want to waste too much time with that. So we already have angle B, which is 49.9 degrees. And now we're missing angle C. The easiest way to find angle C is just finding the angle necessary to complete 180 degrees, right? So we're going to do that. We're going to say that I'm going to do it here. Angle C is equal to 180 minus the addition of the two angles, which are 105 minus 49.9 degrees. So we solve this and we get angle C, the one we're missing, and this is equal to 25.1 degrees. Okay, so you see that this is quite easy. 25.1 would be this one. Okay, so let's see this last example, which is an exam style question, just to make sure that you really understand this. It says, the diagonals of a parallelogram form an acute angle of 62 degrees. The length of the diagonals are 6 centimeters and 9 centimeters. Find the length of the sides of the parallelogram. So first thing, what is a parallelogram? A parallelogram is a quadrilateral which has their sides parallel to each other, right? For example, this is a parallelogram. Let me see if I can draw this clearly. Here. Here. Maybe if I duplicate it, it will be easier. I can put it here and erase this part. And here we have a parallelogram, okay? This is a parallelogram. So I'm gonna trace the diagonals of this parallelogram. I'm gonna use blue to trace the diagonals right here. This one and this one. So it says that the acute angle formed by the diagonals is 62 degrees. The acute angle, well, actually in this figure, yes. The acute angle would be this one over here. The one that is less than 90 degrees, right? This is 62 degrees. And this angle over here, by consequence, would also be 62 degrees, right? Because it's opposite. This is in Spanish called ángulos opuestos. I don't remember the name clearly. It's opuesto por el vértice. That's the name. Ángulos opuestos por el vértice. Okay, and these angles here are the obtuse angles formed. If you realize, all of this should be 360 degrees. So we can calculate these angles. I'm going to do it in green. And you're going to get that this angle right here would be 118 degrees. And this one should be the same, 118 degrees. The addition of all of these angles should be equal to 360 degrees. Okay, then we have the following information. The length of the diagonals are 6 and 9. So if you take a look, this is the shorter diagonal, while this is the longer diagonal, right? So if the whole thing here measures 6 centimeters, then half of this would measure 3 centimeters and 3 centimeters, right? And same thing for this, right? If the whole thing is 9, then half of it would be 4.5, and the other half would also be 4.5. So this is how we correctly sketch this situation. So you see that, what do we want to find? Find the length of the sides of the parallelogram. So we want to find this, and we want to find this, basically. We know that this should be the same as this, and that this side should be the same as this side. Okay, so I just need to focus on, maybe I have to solve two triangles, right? If you take a look at this triangle, this one over here, you see that we could apply cosine rule to find this side length x. I'm going to call this x, and I'm going to call this y, okay? I'm going to use a different color to avoid confusion. I don't know what happened there. This is 4.5. This should be x here, and this should be y here. Okay, so if I want to find x, I see that I can apply cosine rule in this triangle because I have this side, and I have the included angle. So I'm going to apply cosine rule. We're going to say that x squared must be equal to 3 squared plus 4.5 squared minus 2 times 3 times 4.5 times cosine of the included angle, which is 62 degrees. If you solve for this using your calculator, you will get an answer of 4.07 centimeters. 4.07 centimeters. Okay, so we already have one side of the parallelogram. Now we're missing this side, and to find that side, I just apply cosine rule, but using this information over here, which is basically the same information, but the angle changes. Okay, this is 4.5. There you go. So we do the same thing. Y squared is equal to 3 squared plus 4.5 squared minus 2 times 3 times 4.5 times cosine of the included angle, which is in this case 118 degrees. If you solve for this, you're going to get the second result, which is the answer for y. Y is equal to 6.48 centimeters. Okay, so that's how we solve this particular exam style question. Okay, finally, this is a summary of all of the things we have seen up to now. It says, use the Pythagorean theorem in a right angle triangle when you know the length of two sides of the triangle and you want to find the length of the third side. That's a basic thing. Then it says, use SOHCAHTOA in a right angle triangle when you have two sides or one side and one angle. Then use the sine rule when you have the measures of an angle and its opposite side. along with one more piece of information. This is what I always tell you, right? Two information of the same letter, right? Then it says, use the cosine rule when you know the measures of two sides and the included angle, or when you know the measures of all three sides. Or, saying it in other words, when you have three pieces of information of different letters. That's when you apply cosine rule. Okay, so I hope this was clear for you juniors. If not, please let me know. We're going to clear doubts in future live sessions. So thank you for your attention and see you.